How to support more than 500 users at one time on a Wi-Fi network. What I want to achieve is to serve an HTTL server on a LAN. Let's call it a server and give it the address 192.168.0.2. I would like to let people access this server via the browser on their mobile devices, but only if they are connected to the LAN via Wi-Fi. They cannot connect from outside the LAN area like via WAN or something. Normally it would not be a problem unless I want many people to connect at the same time. I've heard that the maximum amount of users that may connect via Wi-Fi is 256, including a server and router, with the subnet mask 255.255.255.0. Changing the subnet mask may increase the amount of users, is that true? But in reality more than 20 to 30 would halt the router. Here come the questions. Are there routers that allow simultaneous connection of more than 200 users? Will changing the subnet mask give me the opportunity to have more than 255 clients in the network? Does Wi-Fi radio bandwidth allow so many users at the same time? Can it be solved via multiple access points? I mean one router and 3 to 5 or more access points. Is it possible to have a DHCP server give users IP addresses from 192.168.0.1 to, for example, 192.168.3.255? Additional info. Security issues don't concern me. There may be no encryption for logging into the network if that makes the problem easier to solve. If there are more expensive but better solutions, feel free to give them to me. A greater amount of access points or a better router is not a problem to buy.
Your questions answered one by one. Are there routers that allow simultaneous connection of more than 200 users? Yes. I'm not making product recommendations, so simply search using your favorite search engine. Common brands are Ruckus, Cisco, Aruba, Zixel, etc. Will changing the subnet mask give me the opportunity to have more than 255 clients in the network? Yes. See more below. Does Wi-Fi radio bandwidth allow so many users at the same time? Yes, and most decent APS have features to manage bandwidth. Can it be solved via multiple access points? I mean one router and 3 to 5 or more access points. Yes, that would be the normal way to do it. APs are limited to a maximum number of clients due to wireless protocol limits, however routers scale much higher, so one decent router will be sufficient for 500 users. Number of APs depends on the actual APS you buy. Is it possible to have a DHCP server give users IP addresses from 192.168.0.1 to, for example, 192.168.3.255? Yes, very simple. A subnet mask of 255.255.255.0 means the last part of the mask can give 0 to 255 numbers, for a total of 256. Out of that, the .0 and the .255 are not used because of how IP routing works, so you have 254 usable. Then one gets used by the gateway, leaving you 253 available client addresses. When the subnet mask is 255.255.0.0, that means a total of 256 by 256 equals 65,536 IP addresses are possible, and after removing the .0.0 and .255.255 and one more for gateway, you have 65533 available. Since you are in a subnet behind a firewall, the only limitation that I can think of will be placed by the router or AP. Home ones can be typically limiting to the last part at 0, but even in the home market not all devices impose the limit. Keep in mind, the subnet mask is simply an IP addressing related limit, and in private networks, it is essentially an arbitrary limit.
I've heard that maximum amount of users that may connect via Wi-Fi is 256. That number is close, however, they will be limited as to the connection speed they are able to obtain. The rule of thumb is 45 devices. For example, a Wi-Fi router rated at 300 megabits per second with 250 devices connected will be limited to an average of 0.8 megabits per second. There are a number of practical limitations. Practical limits of Wi-Fi network scaling: connecting 250 devices to a single Wi-Fi access point, while theoretically possible, is not feasible in practice for a few reasons. On home networks, all devices normally share a single internet connection. The performance of clients' access will start to degrade as more devices join the network and start using it simultaneously. Even just a handful of active devices streaming video or downloading files can quickly max out a shared internet link. Access points overheat and stop working when operating at extreme loads for extended periods, even if handling only local traffic and not accessing the internet. Having a large number of Wi-Fi clients concentrated in close physical proximity, like a home or office building, generates significant wireless signal interference. Radio interference among Wi-Fi clients degrades network performance, due to frequent rebroadcasting of messages that fail to reach their destination, and eventually causes connection drops. You can get around these limitations by adding additional routers or access points. How to maximize your network's potential: installing a second router or access point on a home network can greatly help distribute the network load. By adding more access points to the network, effectively any number of devices can be supported. However, this will make the network progressively more difficult to manage. Source: wireless network capacity: how many devices can connect to my Wi-Fi network? actiontech.com. And a general rule of thumb is to limit the number of simultaneous connections on your home network to 45. However, the specific number is going to vary widely depending on what each of those devices is doing. For example, downloading MP3s, ISOs or other large files requires much more bandwidth than checking email or simple web browsing. Likewise, if the network is hosting web, FTP, or gaming servers, the recommended limit for the number of network connections may be much lower. Source: how many devices can one wireless router handle?
Theoretically, you could even use a network 10.0.0.0 netmask 255.0.0.0 for your Wi-Fi. That would give you enough IP addresses for your users. But that will not be practical. In practice though, you will need to use an enterprise-grade solution. Most home routers stop at around 30 users, dual-band netgears at 64, etc., and you will have to make a routed network with more than 16 access points to make your server available. Enterprise-grade solutions come with a price tag. For example, an Aruba wireless LAN controller with a few access points is easily around €10,000, convert to your local currency, and requires quite a bit of knowledge to set up. Cisco is even more expensive. Meraki is just a bit less expensive and offers a cloud solution that is relatively easy to use, but it may not match your requirements. The number of access points that you need also depends on the protocol that you use. That is Cisco, but other vendors should be comparable. If you are going to use a stack of home routers, then you also have to look at interference. Your 16 routers will have a limited number of bands and they will slow down the connection with other routers. Note also that a stack of 16 home routers is also not very cheap. If you're going to use an enterprise-grade solution, DHCP will be incorporated in that. But get some expert help before deciding on the architecture for these size of networks.
There are a few different limitations at play here. The access point may indeed be able to only accommodate so many users at the same time before the signal degradation is so big that it randomly starts dropping users. This can be solved by using multiple access points, where each can serve different users. Also, Cheaper access points or routers may not be able to handle many users at the same time, where more expensive routers/access points can hold up to 255 users. The second is going to be handing out IP addresses. In order for devices to communicate over the Wi-Fi network/LAN network, each device must receive an IP address. This means that the DHCP server must set a network big enough to hand out more than 255 IP addresses. That automatically means that you have to either create a network with a larger subnet, class B or higher, or divide each segment into VLANs so that they can have their own inner network, which means that people from Group A cannot see and communicate with people from Group B, etc., but all could access your web server if you set it up that way. The second option mentioned here is going to be trickier to set up and cannot be done unless you have capable hardware. That can be as simple as multiple routers with Wi-Fi capability, each serving up to 255 users, and their one port linked to a network behind where your server resides. Also, better enterprise hardware can do this on just one device, but is harder to set up. Therefore, the easiest method is going to be one router with a bigger subnet mask to create a Class B network with more than one Wi-Fi point.